I'm going to walk you through the post-lab assignment for Lab 4, synthesis of salicylic acid from wintergreen oil. Question number 1 has all of your data from the experiment, the mass of methyl salicylate that you used in the lab, so this is going to be a number that you reported from the lab. Also, the actual mass of the purified salicylic acid, so that's something that you weighed out in the lab. And then your melting points. This is all data that you collected in the lab. The rest of these are going to be things that you need to calculate. So the first one on here is calculating the millimoles of methyl salicylate. To do that, you're going to take your grams of methyl salicylate, convert that into moles of methyl salicylate, doing a gram to mole conversion, and then convert that into millimoles of methyl salicylate. So just as a reminder, 1,000 millimole is equal to 1 mole. And then also to do a gram to mole conversion, for a gram to mole conversion, you need to use the molecular weight. Take the mass in grams and then divide that by the molecular weight. For all of these substances, all of your molecular weights are going to be in table 4.1, which is on page 65. That's going to be your molecular weights, and then also your melting points on there as well. The next question is asking you to calculate the theoretical millimoles of salicylic acid. And so this is going to be a mole to mole conversion. This is going to be millimoles of methyl salicylate being converted into millimoles of salicylic acid. And to do this, you need to use the balanced chemical equation for the experiment. I can't spell balanced. The balanced equation for the experiment is on page 65. And actually, I just realized that this is on page 65 as well. So this is a two-step experiment or two-step reaction. You start with methyl salicylate. You convert that into sodium salicylate. And then the sodium salicylate gets converted into salicylic acid. So technically, you're doing a millimole methyl salicylate to salicylic acid and then convert millimoles of methyl salicylate, convert that into millimoles of sodium salicylate, and then convert your millimoles of sodium salicylate into salicylic acid. It's like a tongue twister. Once you get the salicylic acid millimoles calculated, you can calculate the theoretical mass of the salicylic acid. That's going to be the millimoles of salicylic acid converted into moles of salicylic acid, converted into grams of salicylic acid. For the mole to gram conversion, table 4.1 on page 65 will give you that molecular weight. Then down here, you're going to calculate your percent yield. That's going to be your actual divided by your theoretical masses of salicylic acid multiplied by 100. Your actual mass is the number that you measured out in the lab. And the theoretical mass, that's what you calculated right there. And then, of course, just reporting your melting points. So after that, you're going to answer a couple questions from the textbook. These first two are calculation questions. Exercise 1A is asking you to calculate the volume, so however many milliliters of 6 molar NaOH you need for this particular reaction. So that means, first of all, you need to go back to those balanced equations that are on page 65. It's going to show you the balanced equation, stoichiometric coefficient for NaOH. And what you need to do here is to convert the millimoles of methyl salicylate. You probably want to convert that into moles of methyl salicylate and then convert that into moles of NaOH. And then you're going to convert the moles of NaOH into liters of NaOH, which you could leave it into liters or you could convert it into milliliters if you want. Now this mole to liter conversion, that's going to be done using the molarity of NaOH. We know that since it's 6 molar, we know that means 6 moles of NaOH are in every 1 liter of NaOH. So that's the conversion factor that you're going to use for that particular step. And then there's also a second part to this. It asks how much of the 6 molar NaOH that you used was in excess. So you were prescribed a particular volume of NaOH. You're given a specific amount of NaOH did you use, and you want to figure out how much was extra. So how much of it was not used. And that's just going to be a simple subtraction. I can't remember how much you're supposed to use. Like, let's say it's 15 milliliters. And from that, you're going to subtract whatever it was that you actually needed. Like, let's say that's 5 milliliters. So that just means you have like that much left over. That's how much was not used. So then for part B of the same question, what volume of 3 molar H2SO4 is needed to neutralize the sodium salicylate and the excess NaOH present after the reaction? So this is going to take a couple of steps. First of all, you're going to need to figure out your unused or your excess NaOH, excess milliliters of NaOH. And then for that, figure out how much. It says 3 molar H2SO4 is needed to neutralize it. Now keep in mind that these are not reacting in a 1-to-1 ratio. So if you have 1 NaOH and you're reacting it with H2SO4, I shouldn't put the 1 on there, NaOH with H2SO4, they are going to make Na2SO4 and H2O, and you need to balance this equation because you're going to need to figure out the relationship between NaOH and H2SO4. You also need to figure out how much of the sulfuric acid is needed to react with the sodium salicylate. And that, I'm going to just abbreviate that, sodium salicylate. That equation is the one that's on page 65. So the equations on page 65, right above table 4.1, that is showing you the stoichiometric coefficients between sodium salicylate and sulfuric acid. And then you're going to take these two quantities and you're going to add them together. So you're getting the amount of sulfuric acid that you need to neutralize the leftover sodium hydroxide plus the amount of sulfuric acid you need for the actual reaction. And that's how much you need. And then once again, you also are going to calculate how much of the H2SO4 was in excess or was not used. So both of these are pretty labor-intensive calculations. Make sure you give yourself enough time to get through them. They're not easy. They're tedious. You can definitely do them, but they will take some time. Question number 2 is similar to ones that we've done on several post-lab assignments already. This is the type of question where you have some scenarios and nope, that's actually question number 5. I'm getting ahead of myself. So question number 5 is the one where you've got some scenarios. You've got scenario A, scenario B, and scenario C, different possible mistakes that you could have made. And it's just saying explain any effect on your results. So that could be something that affects yield, or it could be something that affects purity, or it could be both. And again, with all of these, you want to take a look at the situation and ask yourself, when is this happening in the experiment? At what point is this happening in the experiment? So what substances are going to be affected by making a mistake at this particular time, and how would they be affected? Now, question number 2 is, go back to that one, exercise number 2. It's asking you to refer to the equation. So we're going to use the equations on page 65 just to get the structures. It's asking you to identify in salicylic acid which hydrogen atoms are most likely to be acidic. Acidic, the way that we're using it in this context, would mean that those are the ones that are going to be removed during the chemical reaction, or the easiest to remove during the chemical reaction. And then it asks you for part B, so this is part A. For part B, it asks you to draw the structure of the white solid that forms immediately after NaOH and methyl salicylate are combined. So in this methyl salicylate plus NaOH, we have 1 mole of methyl salicylate reacting with 2 moles of NaOH to give us our sodium salicylate product. But what it wants you to do is to not draw the structure of sodium salicylate, but to draw the structure of something that is formed prior to the formation of sodium salicylate. And it's going to look like this. It's going to look like something happens with the first molecule of NaOH, and that's what you're trying to figure out. And then a second NaOH comes in, and that's when we get the sodium salicylate. So your job is to figure out what the structure of this guy is, the thing that's formed immediately with the first equivalent of NaOH, not the one at the end.